All right, so we're going to do a static structural analysis. So bring that over. And we'll link the geometries. So click and drag the geometry over. Let's go into engineering data and get our concrete. So we already have the structural steel. Get our concrete. We'll come over to engineering data sources, general materials, and find our concrete in here. All right, so we should have now concrete and structural steel. So we can close out there. And geometry is good. So let's go into our model, double clicking there. There we go, kind of zoomed out a bit. I'll zoom in here a bit again. All right, so let's go put in materials here. So we're going to geometry, and the wheel we want is our structural steel. And for the concrete, we want as our concrete. So let's select our concrete there. All right. Looking back at the sheet, we got the materials defined. Let's look at the connections. We want the global contact to be no separation. So in ANSYS, it's no separation. In SOLIDWORKS, no penetration. So no separation. So let's come back in here. So under connections, we're going to expand that and see contacts, expand that, and click on contact region. So what this is saying is when we brought these two in, this is a place that ANSYS recognized that they are already contacting each other. Wheels contacting the concrete slab. And so if we rotate around here, we can barely see here, there's a red surface. Basically this surface right here on the bottom side of the wheel, down here, is in contact with the concrete slab. So that's the red surface is the wheel, the blue is the concrete floor, and they're in contact right there. So we wanted that to be is not bonded, because what that means is they're fixed, and if they move, they'll move together. They won't deflect those two surfaces in contact with each other. They won't deflect at all. We want them to deflect. We just don't want them to go through each other. So that's why we want to choose here, no separation. All right, we don't want them to come apart and break up. All right, so no separation there. That's good. And okay, so next we have boundary conditions. We want symmetrical faces. We'll put frictionless support, and at the bottom of the floor we'll have fixed support. So the symmetrical faces is right along here where we have symmetry with the floor and the wheel. So we want all those to be frictionless. So we'll click on all those, holding down Control, get all those surfaces. So we'll come up to supports, and we want frictionless support. So that looks good there. And then on the bottom side of our concrete, that will be our fixed support. All right, so those two boundary conditions there. And let's go back here. We're going to do a loading. This is where the bearing load is going to happen. So we want to change vector to components, and we want it to be in the y direction at minus 2,000 newtons. All right, so we'll show this. So vector to components, 2,000 newtons. The bearing load is going to happen here. We said we're going to have a bearing load inside here, inside our wheel, and that's going to be driving downward in the negative y direction. So we already selected that surface, so now we can go up here to loads and do bearing load. And it'll pick up that surface because we already had it selected. And so the sheet says we're going to change vector here to components. And we want the bearing load to only be applied in the y direction, negative 2,000 newtons. And that's all we need to do to apply the bearing load there. All right. And so the last one here is the mesh. So we have the main mesh. We'll just do a medium. And for refinements, we're going to do the inner surface of the hub and the lower hull. And I'm actually going to do that after we saw it the first time. So we'll come back and do that. All right, so for the mesh, let's come in and do the globally. We'll change the sizing to from coarse to medium. And we'll leave it with that for now. All right, and let's look at the deflection. So we'll come in here and we can look at overall total deformation and see what we get there. So we're going to right click and solve. And right click, and solve. Right, so it solved it, but notice these warnings down here. It says one or more bodies may be unconstrained or experiencing rigid body motion. Weak springs have been added to attain a solution for the troubleshooting, et cetera, et cetera. All right, so what happened here is, well, how did we constrain it? We constrained it here, frictionless on this surface, and we said fix the bottom. So what does that mean for the wheel? It can go anywhere. Now, we did do the mating in SOLIDWORKS, but the mating does not fix it in space. It just fixes it. It tells it where to position it in SOLIDWORKS. It doesn't actually fix it where it's at. So we need to have this thing fixed, because basically this wheel could slide this way, it could slide this way, because we have the frictionless support there. So we need to fix this thing so it doesn't go sliding anywhere. So we need to fix, oh, and the weak springs part, this is kind of neat. So what happens is if things start flying away, if the model, in the model it's noticed that things start flying away, it'll apply weak springs to keep them from moving. So the weak springs means that they can still move, it just means they can't take off and disappear. So it's that way we can solve our model, try to figure out what's going on, if we need to apply additional constraints, and then we can fix things before. And then ultimately we want to remove weak springs, but they're a neat thing we can start in. So again, they're virtual weak springs, but it's something that ANSYS can use to help the solution to move forward. All right, so we'll do another frictionless support on a surface over here. So let's go back here, and we're going to click this surface right in here, because that one doesn't move much. So we're going to make that one just be a frictionless support there to keep things from sliding around. All right, so let's solve this again. Hopefully we can get rid of that error. All right, still moving here. So what do we have here? We can slide this way. We constrain it there so it shouldn't slide that way. But it can still go up and down. All right, it shouldn't go up because we have the bearing load being applied down. So it says maybe, which I think will be okay. We'll see how this finishes out here. In this case, we're okay because while it is under constraint, it can fly up. It won't fly down because we say no penetration into the concrete slab. So that's our results here. So let's look at what we got here a little bit better. So we can see it's really deflecting down a lot right there, right? Well, see what's happening. This is millimeters, and we can see the maximum there. That maximum point there is 0.0025 millimeters. So really, this is probably not to scale. It's not. So if we look up here at the result, it's auto scale. So it's 1.5 times 10 to the 4th times the actual value. So if we would go to undeformed or true scale, so this is the true amount of deflection, that's what it looks like. So it really looks like it's essentially undeformed. All right, we could really exaggerate this guy. We could go 2 times. And if we want to go 5 times, right. So again, this is just helping us to see where things are happening. So that was the auto scale that was being applied to it. All right, well, we look over here to make sure we see what's actually happening. All right, so oops, how'd that get in there? Get rid of that one. The other thing I said I was going to do is we wanted to have, going back here, we wanted to do the refinements here. So look at the inner surface of the hub and the lower hole. So let's look where that is. So if we go back here, now let's look at the stress too here. Where do we get the stress here? So we'll go back here and get stress, von Mises, and let's look at that one. Yeah, so we can see the kind of stress that's happening underneath here and in this area. So those are 2 places where we're going to see that we see a large gradient. Zoom in here. Large gradient that's happening. So those are places that we want to make sure we have plenty of nodes to capture what's going on there. Let's see what we kind of nodes mesh we have. Yeah, that's really coarse right now. So let's click right here and right here. Click on those two surfaces. I can hold down Control here. And we'll go into Mesh Control and do Refinement, and we'll just leave it at 1. And let's see what that mesh turns out to be here now. All right, that's a little better. Maybe we can go a little bit more. So click this surface. Actually, we'll come back here in Refinement, and we'll update this. Let's go to 3 and see what we get there. All right, that's a lot better. All right, a lot more nodes in there. Still probably could be more, but I think we might. Hopefully, didn't hit our limit here. Let's see what we got. Yeah, we're still good on the limit. All right, so let's see now if when we solve. Let's look at our stress at those points there. So we'll go ahead and solve this. So now we got a better concentration there. Well, you can see the concentration that's happening. Oops, happening right there, as well as in here. And then we got the mesh to back it up a little bit. Again, the mesh could probably be finer, but you get the sense of where we want to focus in on as we do this. So let me go back to total deflection, and we'll look at this thing overall. And we'll save this as we do our SolidWorks and refer back to it.